everyone. Welcome to our live Q&A. Today we have Alban with us, a research engineer at Meta, to talk about the recent PyTorch 2.5 release. Alban has been working on PyTorch since nearly its inception, first during his PhD at the University of Oxford, and now at Meta. He is focused on maintaining core components, designing a wide breadth of features, and fostering the PyTorch community. Please drop any questions you have for Alban in the comments section, and we're looking forward to doing this Q&A with you. Alban, I'll leave it over to you to introduce us to what's new in 2.5 and anything else you want to share.
Thank you, Jennifer. The 2.5 release just happened last week. I'm sure everyone has seen that. Everyone is excited, and there are quite a few things happening. I'm going to talk very quickly about some of the highlights of the release here for a couple minutes, and then the goal here is to do a Q&A. So I'll be mainly answering questions. I don't have too much speech being prepared for everyone. But I would say in terms of the big release that we have, the big features we have for this release, we are making a lot of changes, obviously, in the LLM space. And people that read the release blog post, I'm sure have realized that there is quite a few exciting features in that end. And I think I'm going to name flex attention, new backends for SDPA, a lot of performance-related features there that I'm sure people are going to be very excited about, both to allow spinning up existing models, so for better backend for SDPA, but also to continue giving people the flexibility to experiment, try out new things. And I think flex attention is really well on that side of the story. Continuing on the flexibility, of course, we have a lot of Torch compile improvement that are been made, and compile to grad is an important one. Regional compilation is another one. You can look in there. There are a lot of things. We are trying to lower compilation time, continue to improve the performance, continue to allow supporting more and more use cases. So there are a lot of things that can happen in PyTorch, and so our compiler needs to handle a lot of these things. And a couple more things I'm going to mention are going to be about support for many platforms. You can see in the release notes as well, we call that the Windows support for Inductor, which is a compiler backend. So we are increasing as well the number of platforms being supported on the compiler side, but also on the Eager side. So you can see there the automatic loading for device extensions, which allows a lot of the community that is building extension for devices that are up and coming, I would say, to be able to be automatically loaded so that you can have exactly the same experience as what you would have when a backend is provided within Core. And more generally, I say you should look out for new upcoming features in terms of how to write device generic code that I am very personally excited about. I think I'm going to stop here with the intro, and I'm going to take questions now. So first question here from Dinesh is, how GIL removal in Python 3.13 affect PyTorch 2.5? So the way the GIL removal in Python 3.13 is done, it's an opt-in. So you actually have two versions of Python 3.13 that were released a couple of weeks ago. For people that are not aware of that, the GIL is the system in Python that ensures safety, but also limits quite significantly how threads can be used in CPython. So now there is a regular version of 3.13 that is available, but there's also a 3.13t on free-threaded, sorry, I cannot pronounce that well, or no-GL version of 3.13 that has this system removed, and so where threading is expected to be a lot more efficient. The current status, I would say, if you want the latest and greatest, you can go on to our issue about 3.13 support on GitHub that has the latest updates. As of today, if you build from source, you can actually use both the regular and the no-GL version of Python. The nightly binaries also support the no-GL version, so you should go and try it out. unfortunately have not been able to do extensive testing for them yet. And so there might be some rough edges. Obviously, this is a very big paradigm changes. So we have made a lot of fixes within PyTorch. We have worked a lot with the community and all our dependencies to make everything more and more thread safe, but we do expect to see some rough edges. So do use the nightly if you're interested in that. Hopefully that works. Report any issue you see. We do expect to be able to provide either in 2.5.1 or in 2.6 a fully released and tested binary for no-gil. But unfortunately, because everything is so new, we don't have all the information yet. Next question. How does Triton fit into this? Is there a path to map to non-CUDA accelerators that depend on PyTorch Triton support? So the way I'm not sure what was the context for this question. The way I read this is what is the link between PyTorch and Triton and how the two work together? I think Triton is a very exciting new project that allows us to have a unique language to write kernels for many different hardware in a very efficient way. So we are obviously from the PyTorch side very excited about that. And I'm sure you know that you can use Triton natively with PyTorch, but also our compiler stack, so the PT2 compiler stack, in particular the inductor side of it, has been leveraging Triton heavily to be able to do multiple backends to handle a wide range of hardware. So if I'm not mistaken, as of today, on Triton, you can support NVIDIA GPUs, AMD GPUs, Intel XPUs. And we also have some more and more fleshed out CPU backend for different kind of CPUs. So there are more and more things being added to Triton. I think from the point of view of PyTorch, in particular the compiler side, we are leveraging as much as possible the multi-backend nature of Triton to allow us not to have to reinvent the wheel. So it's very, very powerful for us. For non-CUDA accelerators, I would say the GPU ones very naturally fit into that Triton story, and that's why we see AMD GPUs or Intel GPUs there. Even non-GPU, I think, is a slightly harder story. I think we have a CPU backend there. I think it is working for some use case. Things that are further away from these kind of systems is not as clear. So what is the story for these? I would say we always have the two sides, which is in the pure eager side, we have all the extension points we need, or you need, to specify your own device and your own backend. Either in tree or out of tree, we should have all the tooling to date for you to do that out of tree. You don't even need the PyTorch core developers to guard basically your integration. You can do it completely out of tree. I was mentioning earlier the automatic loading of these extensions. So your extension will actually feel very much like any other extension any other backend that exists on PyTorch. On the compiler side, that is a little bit of a harder story because it depends a lot on what are your hardware properties and what is the state of your hardware compiler stack as it already exists. So that is why for some compiler, it is much easier to integrate within Triton. And I think for relatively new systems that are similar to GPUs, Triton is a good place because a lot of the compiler complexity has already been factored out there for you. But there are backends. I would mention XLA. I would mention other accelerators that don't have the possibility to have the flexibility of a modern GPU that need what we're going to call full graph, where it needs to know the whole world, or the overhead of launching any work is very high. And these kind of backends need to usually integrate at slightly different places in the compiler stack. I would recommend checking what already exists. We already have integration points at different places there. if you are looking for a good example of a non-Triton backend, I think we have a Halide backend now for Inductor. That is a very interesting one in terms of like showing out a completely new way to look for these things. But there are also other places in the stack where you can plug in, and different users depends a little bit. So if you're a backend writer and you have a new device and you don't know what is the best way to integrate with the stack, I would suggest looking at what exists, but also reaching out to us, because a lot of these extension points are very niche, and we don't expect to have more than 5-10 users for them, and so it doesn't really make sense for us to always spend a lot of time to advertise all of that, given the very small number of users. But if you are one such user, do reach out. I think the Dev Discuss forum is the best place to have these kind of discussions. A question for Joe about creating embedding for mixed data. Do you have any experience with data and best practices recommendations? Tabular and text. So I do not have personally a lot of experience with working on these specific topics. I think it is very, how would say that, challenging. I think it's something we have been discussing actually recently as well within the PyTorch team, which is an interesting shift of, a few years back, the world was a lot simpler. Your whole model was a single D type. Worst case, you were using automatic mixed precision to change only a couple things. But in the end, you had a single D type, a single kind of data coming in, very similar one coming out. It's very exciting to see today LLMs are allowing us to actually go way beyond that. And I think multimodal is a very big theme in all of these things. And you can see a lot of new libraries and new tooling in the ecosystem that is trying to allow these kind of things. I know we have a Torch multimodal that is happening on our end, but I think a lot of other LLM and transformer-based systems are very good at that. My expectation here would be that within PyTorch Core, I don't think we need, at the PyTorch Core embedding layer level, need to handle these kind of things. And hopefully we are already providing you with all the tooling that is necessary to build that yourself from all these building blocks that we're providing in Core. And I think there are a lot of packages, let's say, beyond Core that allow you to do these things. The last thing I would say for this one is, in terms of best practices, my personal experience has always been that, the closer you are to uniform data and to something a GPU can crunch efficiently, the better the end result is going to be, because you are going to be able to do a lot more efficient compute on it. So even, unfortunately, if you think about sparsity and things like that, and less efficient way to crunch the numbers, it seems, or my experience has been that, in the end, if you can crunch a lot more numbers, your result is going to be better than, if you have the right number, but it's so sparse that it takes you a lot of time to handle that. So doing the extra work, I would say, of uniformizing your data in such a way that you can feed everything in a consistent way is usually a very helpful thing to do. When can we expect X-formers to arrive for PyTorch 2.5? So that is a great question. As far as I know from talking to the X-formers team this morning, is within the next few days. I think they are working on some interesting typing issues that they are trying to figure out. And but yes, the release should happen very soon. I would say with more and more libraries in the ecosystem, we are also trying to think of, how do we make sure that they are able to get released as soon as possible. So hopefully this 1 week delay is not going to be, or is going to be reduced coming forward. So do bring it to us when there are specific libraries that you really expect to see available as soon as our regular release is out, and we can work with the maintainers for the release to make sure that it happens as soon as possible. But this one, in the next few days, should be good. So as far as release tested on popular models on training accuracy, so we do have a variety of tests. PyTorch CI is an amazing, humongous piece, I would say. We have a few things. So we have nightly, and on every trunk PR, we run a lot of benchmarking for speed and a little bit on accuracy, based on the most popular models from Hugging Face, Team, Torchbench. And we also have some extra checking, which we call smoke testing, that we do only for the release and when we prepare the release. These are very hard tests, unfortunately, especially the accuracy one, because due to the way floating point accuracy works, we unfortunately cannot guarantee bitwise equality across release, or even if we change the CUDA version, we cannot guarantee anymore that everything is going to behave exactly the same. The implication of that is it's pretty hard to check whether the accuracy of a model is the same, because any small errors that happen at the beginning is going to, increase and potentially is expected to lead to a relatively different behavior at the end, or the threshold of it is a different behavior versus it is just floating point noise is pretty hard to set when you have a relatively big model. The holy grail, of course, here would be we have a set of reference test training scripts, and we would retrain a full model, and the training should converge properly and converge to an equivalent solution in terms of loss, even if the weights are different. Unfortunately, it is quite hard to actually gather high-quality training scripts that A, work and are representative of everything that people want to do, and B, continue to work going forward without a significant maintenance cost. So we are doing as much as we can, I would say, in terms of that. We are welcoming any feedback, of course, when things break, and that's also why we do, our release cycle is so big, because we want to provide the release candidates very early so that people have the time to test them out thoroughly, because we cannot test everything, and people, if it is your model and you try it out, you will know what is expected divergence in terms of floating point numbers versus what is not acceptable, and you can give us a much better signal from there. So we welcome any feedback on that. Of course, if there are things broken, if you think there are models that we should add to our smoke tests, or very specific things that you think we should add to our what we call smoke tests, sorry, these are the tests we do only for the release, do send an issue, do share all that information. I would say anything that is easily reproducible for us, and that doesn't take too long to run, we're very happy to add to our testing. The more we have in our testing, the more we're going to get information about what is going to break, or at least get signal on what we're changing. And we're always interested in getting that signal of what we're changing. So do raise issue, do send it to us, and we'll try to hopefully not make that mistake again. What do we suggest as an alternative to Torchtech, sorry. Now that it's discontinued, you were assessing to move from PyTorch to PyTorch from TensorFlow. Any information is very much appreciated. So I think the migration and why Torchtech is being discontinued is, I think it's taking a step back. The idea is, and my understanding is, Torchtech doesn't fit well within the rest of the PyTorch ecosystem, and that is why we are discontinuing it. And there's no drop-in replacement. There is no, you used to use Torchtech, now you should use that, because I don't think the PCs that made Torchtech Torchtech, sorry, makes sense in the new universe we live in since the past few years with LLMs. And we really think that there are other libraries within the ecosystem that serve basically all of these use cases you might want from Torchtech better, and are going to provide you with a better experience. I think the three main pieces I would mention here are going to be, obviously, there is a lot of basic layers, data loading utilities, very basic things that are now in core, and you should use, I would say, the core utilities directly. You don't need a Torchtech, specialized version of these things because they are now in core. So that's true for a few of the things there. Two, a lot of the LLM specialized utilities to work with text have, I would say, moved beyond what Torchtech was trying to be. And I would suggest looking in other places in the community to look for these kind of components. Hugging Face transformers, I think, is the most popular one, where you can find all the transformer pieces you need in a very reliable way, in a way that moves fast, and in a way that is always up to date. Much better than what we could provide within the context of Torchtech. And three, for people that are more looking as end user solution for Torchtech, I think we have now things like TorchTune that are there to showcase how you should be doing, or how we see you should be doing fine tuning, how we recommend you would be doing fine tuning. Mentioning TorchTune, but there are others in the ecosystem, from Lightning or for Hugging Face, of course, that provide similar functionalities. So we do think that if you are looking for a more end-to-end workflow on doing specifically fine-tuning, service, inference, we do think these specialized libraries are going to provide you with a better user experience than what Torchtech was able to do. And finally, I will also very quickly mention things like Torch Media or like multimedia systems that go just beyond text, because as the previous question was mentioning, we now are in this amazing world of multimedia. And so we are also trying to provide these kind of things beyond just text inputs. So yeah, in summary, Torchtech has been providing us with great tools for a very long time, but today we think that specialized tools, depending on exactly what you want to do, whether you're a researcher, whether you want to do inference, whether you want to do fine-tuning, all of these different things are better served and split into different libraries that are much more effective at giving you what you need. PyTorch is moving away from eager mode with more and more emphasis on Torch compile and new releases. I think the answer is partially yes. I think it's important in my head to keep in mind the Torch compile manifesto that we released alongside 2.0. And I think a very important piece of that Torch compile manifesto is like we preserve all the dynamism and all the flexibility that you've always had with PyTorch, the Pythonic, and all of that. And so, yes, a lot of the features we develop are within compile. A lot of the performance work is done through compile. But you will also see that even when you use compile, you actually use eager a lot. And I think what is interesting and what we are working towards is a much better balance between, when the machine can automatically decide what is the best way to go and when you know better. And I think that better has always been the eager side, where you can, write any logic you want. You can write a custom kernel with, exactly the CUDA code that you want to see. And on the compile side, when there is like very basic fusion that should happen, when there is overlapping that should be thought about, from a compiler, because it's much simpler once they have a graph and all of that. And I think what we're going to do with Torch compile is to find a sweet spot in between the two without getting to any of these two extremes. I think there exists a lot of solution at one extreme or the other, with PyTorch being, PyTorch 1.x being one of these extreme on the eager side. And I think we want to find a sweet spot in the middle where The way I think about it is Torch compile, or like it in the end state, I would like to see something like PyTorch gives you 80% of the best possible performance without you having to think at all about it. And Eager cannot be all the way there because there are fusions. There's a lot of low-level decision that needs to be made. And if you write the code the way you would naturally do it, you will not get, almost at this 80%. So, people learn to do a lot of weird tricks, to overlap compute, to manually do a lot of in-place, to do a lot of these things so that Eager would basically get faster and faster. But you go further away from what would be what I would call the most Pythonic, the most natural code you would write. And I think the goal of compile is to bridge that gap. Just by default, if you write the most natural code that comes to your head, you should go to that 80%, as good as if you were tuning that either code very well. And then if you care about this extra performance, and you are going to spend more time with that model, maybe it's a model that you're going to send to some production system, or you're going to do a much longer training job for it. You care about spending a bit more time with that model, and then you can actually improve the performance gradually through things like removing graph breaks, through giving hints to the compiler on how it should behave better, all these things. And then you have a smooth transition from you were at 80% of the best possible thing you could do all the way to 100%. And the more time you spend working on that, it's a smooth transition. It's not a 0 to 1 where either your model is super slow or you have to spend a month converting it to that compiler, and then it's going to be super fast. Like, we really want to be there. Your most natural code is already very good for any experimentation, any small scale work. It's going to be good enough. And if you really, really care, then you can spend even more time to get further and further in terms of performance, such that you can always achieve state-of-the-art performance. Of course, we want to, for the things that are the most popular, we need to be able to reach the state-of-the-art performance. 80% is not good enough. But it is expected there's a trade-off there between, how fast you're going to be able to enable that model, how much flexibility you have in the code you can write for that model, and how performant it's going to be in the end. Like, there has to be that trade-off. Our goal is really to have a smooth transition in that trade-off. And both Eager and Torch compile play a key role in having that smooth transition. Because there are some things the compiler is going to do better. There are some things Eager is not going to do better. And so we need both of them to work in tandem to achieve that. Hopefully that was a clear enough answer. When I compile a Triton matmul kernel followed by Silu, it's unable to fuse the operation. Fewer will ever have such nice things. So I think the answer is yes. I think the answer, as I understand, is this is exactly the kind of thing where, when I was talking earlier about Eager, providing some of the benefits and compile providing some of the benefit. This is a clear case where compile should be the one providing you with that benefit, where there is an op A followed by an op B. This is the very natural way to write that code, and it should be very natural for the compiler to combine them together. I think the compiler stack, and in particular the low-level compiler being so complex, there are a lot of things that we can and cannot do. And flexibility, I think this one is particularly called Epilogue Fusion for matmul. I think we do it in some very specific cases. I don't think we have a very generic case to do it. I would say open an issue. I think it's a very good feature request. In my head, the best similar example I would have of something like that would be some things like flex attention. So if you take a look at the flex attention we released very recently, it's a similar idea, but instead of just being, I want the activation after the matmul to be whatever I want, it was I want that some custom logic in the middle of my attention layer. So I think these kind of things we could do also a flex matmul. Hopefully we don't have to name that a flex matmul and we can just do that automatically. But yes, this kind of fusion definitely something we should do. Sorry. If you don't see that on the roadmap, do ask it on GitHub. Do raise these kind of things, and we should work on that. Are there any updates for FSDP2? I don't think we are releasing any major changes for FSDP2 in this release. We are doing a lot of work in a few fronts there. I think the two main things are continuing to improve performance and flexibility in Eager. And the second thing is trying to make it more and more compiler friendly. I think the compiler friendly part in specifically has been challenging. And so we are working on that. I think it is getting to the point where it is mature. I'm sure everyone is aware that this is a very big piece of code. And so that has a lot of moving pieces. And transition is always going to be challenging for these kind of things. It is always going to be BC breaking because we want to change how we represent eternal state. We want to change a bunch of these things because we need to change them to get all the benefits of FSDP2. But that also means that any transition is a bit more challenging. So I would say things are coming, and hopefully you should raise an issue. You should try it out and raise an issue you encounter with it. Or if you have specific use case, specific models, do share these with us, and we'll be happy to try and help. For the specific part about what is on the roadmap, in case people don't know, we are trying to get as many of the people contributing to PyTorch, and in particular corporations, participating in the PyTorch Foundation and participating in the development of PyTorch to publish what is on their quote-unquote roadmaps. So I would suggest you go check out the Dev Discuss forum. So dev-discuss.pytorch.org, which is our developer forum, and that has roadmaps from different teams working on PyTorch. The distributed team for Meta that is working on FSDP2 is one of them. So if you go there, you will see what were the plans, at least for H2, so until the end of the year. And once we have the new plan for early 2025, this is where we're gonna send them as well. So if you're curious to hear about more proactively what are the big themes, what are the different teams from different companies working on related to PyTorch, I would follow the Dev Discuss forum where we are trying to get all these roadmaps published. And if any of the components you care about doesn't have roadmaps, do raise it out as well. Community feedback is what helps us, convince everyone that publishing roadmaps is important. So do share feedback about these, and do let us know when you want to see more of that. What are new features introduced for audio signal process modeling? I am sorry, but I do not know about all of these. I think we have a Torch audio library that has been trying to target some of these use cases. I think similar to Torchtech, we have been trying to figure out exactly where it fits in the broader ecosystem. And so I would look into specific models and specific applications that go out with these kind of things, and basically look into these libraries for the latest and greatest. That being for very end user and inference, and for the research side, I think the usual paper screening is the way to go. But I don't have a very good answer here, I'm afraid. Have we seen any issue with the Kian Backend for SDPA? We've been choosing to it for large training runs and got divergence for the previously were stable. Yes, I think there have been a couple issues raised about that specific backend. You can look for Kian and SDPA on our GitHub issue tracker. You should get a lot of the information about that. I'm not sure what you mean here by divergent and stable, if it's about performance or about numerical results. We are definitely aware of some performance issues, and that is because of changes in the layouts of the output that basically were impacting downstream models. On the other hand, in terms of numerical changes, it is hard to say, and that I guess links back to what I was mentioning earlier about the question on how do we test numerical accuracy on the release. It's a pretty hard problem. We do expect the cuDNN backend for ZPA to be slightly different from either the flash attention backend or the math backend, depending on what you were using before. Are these differences significant or not is a very hard line to draw. If you're curious, we had a very long discussion actually about how accurate the what do you say, the math backend should be compared to the flash attention backend, where the math backend was too precise, but also too slow compared to the flash attention backend. So we have these kind of, these discussions are very hard because it's very hard to draw a line between what is correct and not correct. And a lot of these floating point inaccuracies have this annoying property that it's more like if they are unstructured, they are not going to bother you training. But if they have the same scale but are structured, then they can actually divert you training. And so just looking at, run one SDPA layer and see the output, is it the same or not? You will not necessarily be able to with 100% certainty decide whether this is accurate enough, because if it's always biased in the wrong way, it might actually make you training diverge. Well, it's just biased by the same amount of tolerance, but in a very random way, it's just going to average out and your training is going to work out. So very hard for us to say. With respect to your follow-up, yes, that's what I meant by we know we have a different output layout. There's an issue to track that and to fix that. And the implication from a different output layout is indeed that the strides from what the output used to be is going to be different from the stride on this new backend. That has implication in a few ways. Both that has implication that the downstream layers will see, during the forward, we'll see inputs that have a different stride. And so maybe now you're going to call some, channel last version of different layers, or you're going to call slightly different versions of the different matmols and ops, which can have slightly different numerics. And also during the backward pass, because the output has slightly different strides, the grad output will potentially have different strides again, because the downstream layers will potentially end up using a slightly different implementation. And so all of that is quite a bit of jitter, I would call, where you end up using slightly different algorithms for each of these different components. And each of them had some numerical inaccuracies. Some of these are okay, some of these are not okay. Very hard to predict. One thing I would say here is the best way, from taking my maintainer hat, when I see, these requests coming as an issue, I would say the best way for you to report this kind of issue is to, yes, let us know that your model is not training anymore. And I think anything that can narrow down the reason, either with, you train a fake model, the old version, and the fake model on the new version, and show that there is some numerical, like anything that can make it possible for us to reproduce that kind of error is usually the best, because that means, we can quickly iterate locally and figure out what is going wrong without having to ask you every time, oh, can you try and do that? You do a training run, and then we suggest more things, and that just takes a long time. So if I'm very sorry you are seeing these kind of issues. I think being able to narrow down these kind of issues is always an amazing skill to have. And the more you can do that on your end, because you can do that a lot faster than unfortunately we can do, the better. And the faster your issue and your convergence problem is going to get root caused and fixed. But yeah, thank you for reporting these kind of things. Luca is asking, anyone found a full list of GPUs that support the new Kian Backend for SDPA besides the H100? I am afraid I do not have a good answer for you on this one. Not being a Kian and SDPA expert on my end. My expectation would be that there are two things that are going to potentially influence that. A is what cuDNN itself natively supports, and that you should be able to get that information from the cuDNN release itself, and from NVIDIA's documentation on cuDNN. Depending on whether you compile PyTorch from source or you consume our precompiled binaries, any of that, you can use very different versions of cuDNN with PyTorch. So if you need a very specific version of cuDNN, you usually can get away, in the worst case, compiling from source or finding the binary that we provide that has the right version for you. So that is one side. The other side is, our integration that translates from our end user API for SDPA all the way to cuDNN, and that as well has some decision making. On that side, I would suggest looking in the SDPA backend selection logic that we have. That is where you are able to force a specific backend. So, by default, we are only going to run the cuDNN backend when we think it is going to be stable, the fastest backend possible, and the best thing overall. But if you know better, and you know that for your use case, what cuDNN provides should work well, even though it's not our default, you have a backend selection logic within SDPA that you can use and force something to happen. So I think these two things you have to look into. Unfortunately, I don't have a out-of-the-box answer for you, but hopefully that will allow you to find exactly the answer you're looking for. When should people use official release versus nightly builds or the GitHub main branch? That is a great question. I would actually change it slightly to two pieces. And one is, when should you use the full, what I would call like full release, so 2.5.0, 2.5.1, versus nightly releases. Nightly releases, for people that are not aware, if you go on the Get Started page, you have a preview selector that will allow you to use a fully packaged binary, just like the full release, but that was built with last night's version of PyTorch. So basically, when something lands in the main branch on a day and all the CI is green, then in the next morning, if you install the nightly, you're going to get that change. I think the main difference between these two is how interested you are in the latest and greatest features in PyTorch. So depending on which subcomponents of PyTorch you're using, I would say if you're using mostly the stable pieces that have been there for a long time but are not changing very fast, like you're only using TorchNN and Optim and AutoGrad and basic distributed systems, and then you're using custom code on top of that, or you're using transformers or things like that, 2.5 release is most likely the way to go. Especially if you're more interested about the stability of the core components than the latest and greatest feature. If, on the other hand, you want to use some of the features that were released much more recently, like the latest Torch compiled passes, the latest compiler performance, the latest distributed feature, the latest tensor subclass features, all these kind of things, I would recommend running on the nightlies because there are a lot of bug fix that we have to do. And it is, when using this kind of feature, it is more important for you to have all the latest bug fix than it's more important for you to have all the latest bug fix than the stability of what was snapshotted a couple of months back. So that is the split I would do for, do you want to use the nightly versus not the nightly? And hopefully that should give you a good idea. For the second part of your question, which was, should you use the main branch? I read that as, should you build from source or should you use the nightly? And I think these two are very different things, because I would say I would not expect you have to build from source unless you need to have a very specific version of a dependency that you need, like an older CUDA version or a very specific way to integrate with other C++ libraries, or a very specific cuDNN version. These kind of things you will need to build from source. But unless you need these kind of things, I would recommend using the prepackaged binaries because it's most likely going to be a lot simpler for you. One thing I would say is, even if you build from source, you can also build from source from the 2.5 released snapshot. So these two things are kind of independent, right? Whether you want the latest and greatest or the most stable tells you whether you should build on the latest nightly branch or the 2.5 branch. And whether you need custom dependency or not tells you whether you can use a prepackaged binary, either nightly or for release, or you have to build from source from either of these 2 points. But I think all 4 points in that quadrant, in that cross section, are valid, depending a lot on basically what you need from things. Given a PyTorch release main nightly, how can I find all the tests that were run for that specific release? It seems sometimes only run on PRs. So I would show you, I would suggest looking at the HUD. So we have what we call the HUD page. If you send a PR to PyTorch, you should have seen that comment in your PR pointing to some HUD page. So if you go to hud.pytorch.org, you have the CI status for everything in PyTorch, basically, and every commit that ends up in the main branch. So everything that runs on PR is actually a subset of what runs on every commit that ends up in the main branch. So we do not have anything that is run only on PRs, no. Everything that is run on PR is also run on the main branch. There are also things that are periodic things on the main branch, meaning they run at most 2 or 3 times a day because they're usually very expensive things. And so that is for the every single commit on the main branch. Then the way nightly works is basically at 2 a.m. EST or something like that, we take the last commit on the main branch where the whole CI is green. So whatever was the last perfectly passing CI commit in the main branch is what becomes the new nightly. So if you are looking at a HUD and every commit in the main branch, you will know all the tests that run basically for also the nightly, because something becomes the new nightly if it passes all green, or one of the commit after it was all green. So it is a little bit of a challenge. I would recommend spending a bit of time on the HUD page and understanding how every commit there works, what are the CI, how to look at all of that. But the theory, and hopefully also the practice, is any test we have in our CI, if it is broken, will prevent that. So first, it should prevent that from landing in main. Sometimes, there is land races. There are many reasons that could lead to things landing in main and end up being broken in the main branch. The HUD should very clearly tell you when that happens, and we usually try and reverse as soon as possible. But if you have a test in CI, there is no way for it to end up in the nightly, because if the test is broken, it's going to be a red line, in the main timeline, and that will prevent nightly from picking that up. So hopefully that answers partially your answer. For nightly, everything that is tested in CI that is not, disabled or something like that should not be able to fail on the nightly. So that's why we expect our nightly to be relatively stable. Going back to the previous question on when should I use nightly versus releases, that's why I'm saying, it's pretty safe to use nightlies if you are using some of these more recent features, because we only get a nightly out if CI is all green. And so hopefully anything you do should have some coverage in CI. And so that should prevent nightly from very obviously breaking you. Of course, things can slip through cracks all the time, but that is our goal. If anything doesn't behave like that, do report it to us, obviously.
Thank you, Alban. I just wanted to say if anyone has any remaining questions, we are getting close to time, but please drop those in the comments. We can do a couple more.
Yeah, what are the initiative plans for libtorch, the C++ PyTorch backend? Anything related with augmentations? I am not sure what you mean by augmentations here. If you can drop a clarification in the chat, I would be curious to hear that. But the near future plans for libtorch and the C++ PyTorch backends, I think in my head there are two parts of what libtorch is. And I think one of them is what I would call a full-fledged deep learning framework with that is written purely in C++. And that is what is in the torch/include C++ headers, where you have an equivalent NN namespace there. You have an equivalent optimizer namespace. You have an equivalent autogram namespace, all of that. So it is, trying to be a full-fledged deep learning framework for pure CPP users. And on the other hand, we have also the libtorch part that is geared towards people that want to extend PyTorch from C++, so that are writing custom CUDA kernels, that are writing custom C++ kernels, that are trying to run inference in the C++ and only environment. All these kind of things are also using libtorch. So for the first one, which is a pure C++ deep learning framework, I don't think we have, unfortunately, any big plans for it. The reason is we have a relatively limited set of users that are passionate about that. And we are struggling to find a long-term maintainer for that piece. And it is a very complex piece, right? Because you are trying to get the full API surface of everything a deep learning framework would need to provide written in C++. And given there are not that many people working on it, of course, it's a very daunting work. If you are interested and passionate about that, do reach out. We are looking for maintainers for this piece, but it's not a very high priority. And the reason for that is because of the other side of the hand, I would say, which is I think PyTorch is moving towards that mixed Python plus C++ more and more, where in particular with the more advanced compiler stack that used to be TorchScript, that is now going through export, AOTI, things like that. And all the new custom op APIs we provide, we don't think most of the users need to write the whole model in C++ anymore. And you can actually get similar performance, if not very different programming model, very different experience, but you should be able to get the same performance from writing your model in Python, and then it being lowered either through our stack, compiler, or Eager, or through some custom kernels that you're going to write yourself. And that part we are very heavily investing into. I will mention the new custom mobs API that allow you to extend PyTorch from C++, but also doing C++ extension from Python. We've been doing some very, I would say, cool, some other people would say horrible things that allow you to, replace some of the C++ backend by your Python logic. It's amazing to do experimentation. The performance is not even that bad. It's bad if you do small ops, but if you do big ops, it's not even that bad. And it's very cool to try out new things, to do very big fundamental new ideas within the framework. This is actually a very big game changer. So these new custom ops APIs, new, I would say, C++ packaging things that we are heavily working on, and I would say the new inference stack where we are continuing to provide a C++ environment runtime for inference. So, we are considering that when you are doing training, there is such big ops. The Python overhead is not big enough for most of the users, and I would say almost all of the users don't care about the Python overhead there. You should use Python. But there are things when you do inference for very large scale, you need these last few percents, or you need some more predictability in your workload, and so you don't want Python GC to kick in at the wrong time, things like that. We are going to provide some C++ inference systems so that you can get these benefits, but they are definitely not for everyone, I would say. The inference story, and there is a very good talk and poster from the PyTorch conference about that. I would recommend you go read that. It's going to be much better than what I can say here, but I would say most people, I would expect, can still use Python because it's going to be fast enough for a lot of the workloads we have today. Some people will want to use ahead of time compilation and AOTI utilities like that have still a full PyTorch backing it and all of that, but no just-in-time compilation, no Python runtime, so a lot more predictable. And I would say even all the way to things like ExecuTorch, if you're interested in kind of things, that is very much targeted for like hard runtime constraints. So if you're on mobile, if you're on like edge devices, where it's a very slim runtime, it's going to be able to do memory planning. It's going to be to do these kind of advanced features you need in very low binary size world. But I would say as you go down these stack, is going to put more and more constraints on what you can do in your model, because if you need to get away from Python, any fancy Python logic you have, you won't be able to use. So, you get more performance, more predictability, but it comes at a cost at, the flexibility of what you can do in your code. And so it is something you will need to decide, I think, for your specific use case. And it's not even something where you have to pick one and forever stay with it. Like, you can have a lot of your, experimentation stack running Python all the time because, being 5% slower is not really a problem there. But once you select a model and you're like, oh, we are going to train this one for a couple of weeks, then you do the extra work of, okay, let's remove Python from it now. And we might have to change the code. It might be a bit painful, but now we get 5% more perf, and we care about this 5%. So we only pay the cost, and we only pay the pain of updating the model when we know it's going to be worth it. So I think this is where we stand on that one. Hopefully that clarified on the C++ backend. So C++ for specific use case, we do really care about it, but not for all. And there are some use cases where we recommend you stay with Python because it's going to be a lot more flexibility for you, and you're going to be able to move a lot faster in getting the code you need to run.
All right. Thank you so much, Alban. And thank you, everyone, for your questions. We are at time. Is there any final word that you wanted to share?
I didn't plan last words. No, I think the final words would be, well, thanks for the question. I think these were all very interesting. I think PyTorch is spanning so many users and activities now. Someone was asking how old PyTorch is. I think it's 7-something years now. So things have changed. Some things are for historical reasons. A lot of things are happening. So the main goal of PyTorch is going to continue to be like make it easy for all you guys to do what you want to do. So give us feedback. Open issues when things don't work, open feature requests when you want to see things change, participate in the forum when you want to do these kind of things. We have a contributor guide as well now, wiki, if you want to participate in developing PyTorch. There are a lot of things happening. We always need help, and we always want to hear more from you. So don't hesitate to reach out if you have anything you want.
Yes, agreed. And you can also follow PyTorch on social channels to be notified of any upcoming webinars or Q&As like this. So thank you so much for your time, Alban. Thank you, everyone, for your questions. Any remaining questions we'll answer in the comments. Thank you. Bye-bye.
Thank you.